Right. So in today's class, we are going to discuss about interconnection of two. Mainly, we are discussing about the two-port networks. We can go beyond two also. So we are going to discuss about the interconnection of the different two-port networks. So let us assume I have a two-port networks. Two-port networks. See, let us assume this is the one two-port network and this is the another two-port network. Okay. So let us assume I have a two-port networks, and I know the two-port network parameters of the each two-port network. I know the two-port network parameters of each two-port network. Now, if those two-port networks are interconnected, then what will be the two-port network parameters? I think you understand. I will repeat once again. Let's assume I have two-port networks, and for each two-port network, I know the two-port network parameters. Now, I am going to interconnect the two-port networks. I am going to interconnect the two-port networks. And after interconnecting, how I am interconnecting, we are going to discuss. So that may be a cascade connection, or that may be a series connection, or that may be a parallel connection. But let us assume I am trying to interconnect two-port networks whose two-port network parameters are known. Now, after interconnecting, we know the new two-port network, right? I have one two-port network and I have another two-port network, and I'm joining these two-port networks. Then I have only one two-port network now after interconnection. So after interconnection, we will get the only single two-port network. For the two-port network, how we going to calculate the two-port network parameters? Based on the two-port network parameters information available for each two-port network, right? అంటే తెలుగులో చెప్తున్నాము ఒకసారి చూడండి. నా దగ్గర ఒక టూ-పోర్ట్ నెట్వర్క్స్ ఉన్నాయి. ప్రతి టూ-పోర్ట్ నెట్వర్క్కి దానికి టూ-పోర్ట్ నెట్వర్క్ పారామీటర్స్ కూడా నా దగ్గర అవైలబుల్ ఉన్నాయి. ఇప్పుడు ఆ రెండు టూ-పోర్ట్ నెట్వర్క్స్ని కనెక్ట్ చేశాను. ఆ కనెక్షన్ అనేది మేబీ క్యాస్కేడ్ కనెక్షన్ కావచ్చు, సిరీస్ కనెక్షన్ కావచ్చు, ప్యారలల్ కనెక్షన్ కావచ్చు, ఏదైనా ఆ రెండింటిని ఇంటర్కనెక్ట్ చేశాను. సో వన్స్ ఆ రెండు టూ-పోర్ట్ నెట్వర్క్స్ కూడా ఇంటర్కనెక్ట్ చేసామనుకోండి, ఫైనల్లీ వీ విల్ గెట్ ద వన్ టూ-పోర్ట్ నెట్వర్క్, రైట్? సో ఇప్పుడు ఫైనల్ గా డెవలప్ అయిన ఆ సింగిల్ టూ-పోర్ట్ నెట్వర్క్ యొక్క టూ-పోర్ట్ నెట్వర్క్ పారామీటర్స్ ఎట్లా క్యాలిక్యులేట్ చేయగలము? బేస్డ్ ఆన్ ఆల్రెడీ మనకు ఈచ్ టూ-పోర్ట్ టూ-పోర్ట్ నెట్వర్క్ పారామీటర్స్ అవైలబుల్ ఉన్నాయి కదా, ఆ ఇన్ఫర్మేషన్ యూజ్ చేసుకొని కొత్తగా జనరేట్ అయిన టూ-పోర్ట్ నెట్వర్క్ యొక్క టూ-పోర్ట్ నెట్వర్క్ పారామీటర్స్ ఏ విధంగా క్యాలిక్యులేట్ చేయాలో వీఆర్ గోయింగ్ టు డిస్కస్ నౌ, రైట్? ఓకే. సో ఫస్ట్ వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ cascading connection of two-port networks. See, just I am dictating for the two-port networks. That number of interconnection may be beyond the రెండు two-port networks li interconnect cheyalanedi na uddesham kaadamma. Just for the demonstration purpose, I am telling only two-port networks. But we can consider multiple two-port networks, not restricted to. You can take 2, 3, 4 or whatever it may be. Right. So now we are going to discuss about the cascade connection of the two-port networks. So I have one two-port network. See, this is the one two-port network whose input voltage is VA and input current is IA. Output voltage is VB and output current is IB. And A1, B1, C1 and D1. A1, B1, C1 and D1 are the ABCD parameters of the first two-port network. A1, B1, C1 and D1 are the ABCD parameters of the given first two-port network. Similarly, I have another two-port network having the input voltage VC and input voltage IC, input current IC, and output voltage VD and output current ID. And this two-port network has the two-port network parameters A2, B2, C2 and D2, right? That means for this two-port network I have the ABCD parameters, and for this two-port network I have the ABCD parameters. Now if I am connecting these two-port networks in a cascading manner, then what will be the new ABCD parameters of the final established two-port network? So what means the cascade connection? We will see. Cascade connection is nothing but the output port of the one two-port network is connected to the input port of the another two-port network. Cascade connection is output port of one two-port network is going to connect it to the input port of the another two-port network. Means it will be like this. This is the output port. Output port is connected to the input port of the another two-port network parameter. Similarly, the output port is connected to the input port of the another two-port network parameter. So this connection is called as this connection is called cascade connection. See, after if you connect these two and if you connect these two, now we have the only one two-port network. Now this is the input port and this is the output port, right? Now after cascade connection, we are going to see single two-port network having the input voltage VA and input current IA, output voltage VD and output current ID. This complete two-port network containing the two-port networks. One is this one, another is this one, but these two are connected into the cascade connection. So finally, we establish only one two-port network with the input voltage VA and input current IA and output voltage VD and output current ID. Right? Good. See, in the below matrix, you can easily understood that if A1, B1, C1, and D1 are the ABCD parameters of the given two-port network one, and A2, B2, C2, D2 are the ABCD parameters of the second two-port network. If the first and second two-port network connected cascading way, that means output of the first two-port network connected to the input of the second two-port network, then finally a new two-port network was developed with input voltage VA, input current IA, output voltage VD, output current ID. Now, for complete two-port network, the ABCD parameters A, B, C, D are easily calculated by multiplying the ABCD matrix of the first two-port network and ABCD matrix of the second two-port network. That product of those two matrices, multiplication of those two matrices will provide the ABCD parameters of the new two-port network which was established by cascade connection of the given two-port networks. I hope you understand. See, A1, B1, C1, D1 are the A1, B1, C1 and D1 are the ABCD parameters of the first two-port network. A2, B2, C2 are the ABCD parameters of the second.
Sir, we are not able to hear your voice, sir.
Now you are able to, please. Hello. Are you able to hear me?
Yes, sir.
Right.
Yes, sir.
Okay. So, see, A1, B1, C1 and D1 are the ABCD parameters of the first two-port network and A2, B2, C2 are the ABCD parameters of the second two-port network. If these two-port networks are connected in cascading way means output of the one first two-port network connected to the input of the second two-port network. Now we will get the one new two-port network. This new two-port network has the ABCD parameters that's equal to multiplication of the ABCD matrix of the first two-port network with the multiplication of the ABCD matrix of the second two-port network, right? So now this is the equation. This you can answer. That means if we know the ABCD parameters of the first two-port network, if we know the ABCD parameters of the second two-port network, and if you multiply these two matrices, we will get the ABCD parameters of the net to final two-port network which was formed by cascading connection of these two. I hope you understand. Right? Now, we will discuss how this equation we are able to get. Now, we need to concentrate on how we get this relation. How we get ABCD equal to A1, B1, C1, D1 multiplied with A2, B2, C2, D2. So now we need to derive it. So this derivation is useful for understanding and useful for the academic purpose. But however, for the competitive examinations, if you are able to understand this concept, able to understand this equation, that is sufficient for you to solve the problems in the competitive examinations. Anyhow, now we are going to discuss about derivation. Now we will discuss in the derivation. Right. 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 Okay. See, now first concentrate on the first two-port network. Okay, having the ABCD parameters A1, B1, C1, and D1. Right. Now, tell me what is the relation between VA and IA in terms of VB and IB using the ABCD parameters. Right? Note down the equation first. Understood now? So what I want to develop the relation between VA and IA in terms of VBA and IB using the ABCD parameters. Right? So what is the value? VA equal to A1 multiplied by VB, right, minus B1 multiplied by IB. Okay, nama? Good. Similarly, IA equal to C1 multiplied by VB minus D1 multiplied by IB. Right, good. So this is the ABCD parameter representation of the first two-port network. Okay, good. Next. Now represent the input voltage and input current of the second two-port network. Those are VC and IC in terms of output parameters VD and ID using the ABCD parameters in the second two-port network. In the second two-port network, that means here in the second two-port network. So that's equal to VC equal to A2 multiplied by VD, right? And B2 multiplied by ID. Similarly, IC equal to C2 multiplied by VD minus D2 multiplied by ID. Is it okay, Nama? Right? Right? So this is the ABCD parameter for the second two-port network. This is for the first two-port network. Okay? So keep it aside. Okay? So this is for first two-port network. And this is for second two-port network. Right? Now, suppose if we cascade these two-port networks, that means if we connect the output of the first two-port network with the input of the second two-port network and assume the two ABCD parameters of the obtained two-port network after cascading connection are A, B, C, and D. Right? Now, anyone can tell me what is the relation between input voltages and input voltage and current and output voltage and current in terms of the ABCD parameter after cascading connection. So what is the equation now? After cascading. Anyone?
VA.
V? Anyone? After cascading
VB equals to VC.
No. What I'm expecting is what is the I want to after cascading connection. I want to represent the input voltage and input current in terms of the output voltage and output current in terms of the ABCD parameters. That equation.
VA equals to
VA equal to
A into VB minus.
Right, good. A into VD because okay, A into VD minus B
into ID.
Good. ID.
D.
Similarly,
IA equals to C into VD
minus D multiplied by
into ID.
Because after cascade connection, we have the only single two-port network having the input VA and IA, output has VD and ID, and VD and ID. I want to represent in terms of the ABCD parameters. So like this, right? Now keep all these things aside. Now, see, in very initial class, I told that in every two-port network, we are going to assume the currents are moving towards the port, right? Towards the port, right? Now, anyone can tell if we do the cascade connection between the two-port networks. If you make the cascade connection between the two-port networks, now what is the relation between IB and IC, and what is the relation between VB and VC? Anyone can tell? After cascade connection, what is the relation between IB and IC and VB and VC? ఎవరైనా చెప్పగలరమ్మా?
ఈక్వల్.
ఏంటి ఈక్వల్ ఉంటాయి? టూ స్టేట్మెంట్స్ చెప్తాను వినండి. In a very first class, I told that in the two-port network, we are assuming that the direction of the currents entering toward the port, towards the circuit, towards the network. Okay, that means this IB is the current, output current of the first port that represents towards the net port, and IC is the input current for the second two-port network, and that towards the network, right? Now, what is the relation between this voltage and currents? So, can I write VB equal to VC?
Minus.
Right? VB equal to VC, and can I write IB equal to minus IC? Are you okay? ఎందుకంటే మనకు ఫస్ట్ క్లాస్లో చెప్పాను ఏంటంటే for any two-port network, we are assuming that the currents are entering towards the network. That means IA toward this network, and IB towards this network, and IC toward this network, and ID towards this network. So IB is towards this first port, and IC is towards the second port. And if you interconnect these two, so IB is towards this one, and IC is towards this one. That's why I'm taking the IB equal to minus IC. But whereas the voltage will be same. The voltage will be same here VB and here VC. That's why I'm taking the VB equal to this. Right. Now what we have to do is, see friends, so VA equal to first equation. ఒకసారి ఫస్ట్ ఈక్వేషన్ అబ్జర్వ్ చేయండి అమ్మా. ఫస్ట్ ఈక్వేషన్ ఏం చేస్తానంటే I want to write like this. VA equal to A1 multiplied by VB minus minus B1 multiplied by IB equal to minus IC kadamma. Just I will keep here minus IC. Minus IC. Is it okay? So equation ఏమవుతుంది మనకు? Now this equation becomes A1 multiplied by VB minus into minus plus B1 multiplied by IC. Right? Similarly, IA equal to C1 multiplied by VB, C1 multiplied by VB, and minus D1 multiplied by IB. Right? IB kadamma? IA equal to C1 into VB minus D1 into IB kada. So IB place we can write minus IC. So just I want to write minus IC in place of IB. Now we can further simplify this one as A1 multiplied by VB and minus into minus plus D multiplied by IC. Are satisfied up to here? Is it okay now?
C1 into VB.
Thank you. Yeah, D1, eh? Right, D1 into IC. Here also. Is it okay, Nama?
No, sir.
C1 into VB.
Amma? Did I made any mistake? ఇక్కడ ఏమైనా ప్రాబ్లం ఉందమ్మా?
No problem, sir.
No, sir.
Okay, done. Right. Now what we have to do is see, and one more thing. Here see, VB equal to VC kadamma. Here VB equal to VC kada, right? So we can keep in place of VB, we can replace with VC. In place of VB, we can replace with VC as VB equal to VC. Okay, Nama? So as VB equal to VC, A1 into VC and C1 into VC. Because VB equal to VC kabatti, in place of VB, I am placing the VC. So A1 into VC and C1 into VC. And IB equal to minus IC kabatti, here I am taking the minus IC, here also I am considering the minus IC. So it will become plus V1 into IC like this. Okay? Now what I have to do is, now I want to replace VC with this one, and I want to replace IC with this one, right? So replace VC and IC by using these two and see the what happened. So VA equal to A1 multiplied by VC and entama VC equal to A2 multiplied by VD, and A2 multiplied by VD minus B2 multiplied by ID, right? That is the VC, right? Plus B1 multiplied by IC and IC. So IC equal to this one. Just replace it.
C.
C2 into VD, right? That's it. Okay, right. Next thing. Now what is the IA? So IA equal to entama C1
C1
into VC kada.
into
So C1 multiplied by VC means this one. VC and plus ఇంకేం వస్తుందమ్మా C1 into VC plus D1 multiplied by IC kada. So IC nothing but this one. Sorry, IC. Right? Now try to multiply inside and try to separate VD as common. So what I want to see is VA equal to inside multiply చేయనమ్మా ఏమొస్తుంది మనకు చూడండి A1 into A2 multiplied by VD minus A1 multiplied by B2 multiplied by ID plus B1 multiplied by C2 multiplied by VD minus ఇంకేముందమ్మా B1 multiplied by D2 multiplied by ID, right? So now from here VA equal to, so take VD common. So if VD common this one came up here only. If take VD common, we have A1 into A2. So A1 multiplied by A2. ఇంకేముందమ్మా ఇక్కడ
Plus B1 multiplied by C2.
ఇదేనమ్మా. If you take VD common,
B1 multiplied by C2.
plus B1 multiplied by C2 into VD, right? If you take VD common, we have the A1 into A2, and if you take VD common, we have the B1 into C2. These two are the addition. Similarly, if you take minus ID common, if you take here, I have the minus ID, and here also I have the minus ID, right? So if you take ID minus ID common, so what we have minus common minus ID తీసామనుకోండి, we have what we have
A1 B2
A1 B2 plus B1 D2.
A1 into B2
A1 B2 plus B1 multiplied by
D2.
B1 D2
D2.
So that is the ID, right? That's it. So keep it aside. Now similarly from the second equation here, IA equal to here idam multiply with C1 inside, then we have C1 multiplied, so C1 multiplied by A2 multiplied by VD minus C1 multiplied by B2 multiplied by ID, right? C1 multiplied by B2 plus D1 C2 VD, D1 C2 VD, right? And what else? Minus D
D1, D2, ID.
D2 into I. Right.
D.
Now, from the above equation, try to separate VD terms and minus ID terms. Huh? So, if you take a VD term outside, so here we have the C1 multiplied by A2. VD
C1
A2
D1 into
A1
C2.
multiplied by C2
C2.
AB common, and take minus ID, then we have C1 multiplied by
C1, B2 plus
B2 plus D1 multiplied by D2 and ID outside. I'm taking the ID outside. Is it okay, Nama? Right. Good. Now, see, so now this is the VA and this is the IA after cascading connection, right? So that means I'm getting the VA in terms of VD and ID. I'm getting the IA in terms of the VD and ID. That means, see, we have the VA in terms of VD and ID, and we have the IA in terms of VD and ID, right? Understood, na? That means these two equations which provide the input voltage and input current relation in terms of the output voltage and output current equations after cascading connection. So if you compare these two equations with this equation and also with this equation, anyone can tell what is the value of A. A equal to what?
A1 into A2 plus B1 into C2.
A1 into A2 plus B1 into
B1 into C2.
C2. Right, good.
2.
B equal to
C2.
B and
A1 into B2 plus B1 into D2.
A1 into B2 plus
A1 B2.
ఇది కదా right. A1 into B2 plus B1 into
B1 into D2.
B1 into D2, right? Now, what is the C? C means
C1
for IA,
C1 into A2.
IA VD coefficient. ఏమొస్తుందమ్మా? C1 into A2 plus B1
plus
into C2, right? Right. And D equal to ఏమవుతుందమ్మా?
C1 into B2.
D means in IA.
C1 into B.
That means this one. C1 into
B2.
B2 plus D1 into D1 into D2. అంతే కదమ్మా? So finally we have the ABCD parameters of the two-port network which are obtained after cascading connection of the two two-port networks having the ABCD parameters A1, B1, C1, D1 and A2, B2, C2, D2. So if you observe these equations, see A equal to A1, A2 plus B1, C2 కదమ్మా. ఇప్పుడు చూడండి, ఇది ఏ కదా, ఇక్కడ ఈ రెండు మల్టిప్లైస్ ఏమొస్తుంది? ఫస్ట్ ఎలిమెంట్ ఏ కావాలంటే ఏం చేయాలి మనం? A1 into A2 plus B1 into C2, రైట్? ఓకేనమ్మా? A1 into A2 plus B1 into C2, that's equal to
Yes,
A. That's what we got here. A1 into A2. Similarly, B కావాలంటే ఏం చేయాలి? We have to multiply this one with this one, right? That means A1 into B2 plus B1 into D2. A1 into B2 plus B1 into D2, that's either B, right? Similarly, if you want to see what you have to do, you have to multiply this one. You have to multiply this one with this one, right? That means this column. That means second row with the first column, you will get the C. Okay? Second row with first column. That means C1 A2 plus D1 C2 plus D1 C2, that's the C. Similarly, how we get D? So D equal to, say, second row of the first matrix with the second column. That's equal to C1 B2 plus D1 D2. C1 B2 plus D1 D2. Understood, Namma? I think you understood this derivation. That means, so final conclusion is So see, just I'm explaining the derivation for the only two port networks. Suppose if you have the if you have three two-port networks and having the ABCD parameters A1, B1, C1, D1, A2, B2, C2, D2, and A3, B3, C3, D3, and all three are cascade connected, then the two-port networks after cascade connection, ABCD values, that's equal to the just matrix multiplication of A1, B1, C1, A2, B2, C2, and A3, B3, C3. Just simple matrix multiplication. That's it. Okay? Right. So just we are 4 minutes away. Just I am trying to summarize. I hope you understand this complete derivation. I'm trying to summarize. So in today's class, we discussed about the cascade connection of the two two-port networks. Let's assume we have the two two-port networks having the ABCD parameters A1, B1, C1, D1, and ABCD parameters A2, B2, C2, and D2. Now these two two-port networks are connected cascading way. Cascading means output port of the first two-port network is connected to the input of the second two-port network. That is called a cascade connection. So after cascade connection, so now the two two-port networks will be connected cascadingly. So finally we have the only single two-port network with the input voltage VA and input current IA, output voltage VD and output current IT. Now what are the new ABCD parameters? We know the ABCD parameters of the first port. We know the ABCD parameters of the second port. Now what are the ABCD parameters of the two-port network which was obtained after cascade connection? That's equal to the simple matrix multiplication of the ABCD parameters of the two-port networks. Right? I hope you understand what is the cascade connection, and I hope you understand how we calculate the ABCD parameters after cascade connection. If you know the ABCD parameters of the given two-port networks, there is no need to restrict it only for the two. You can take any 2, 3, 4, 5, whatever it may be. Right? It's simply matrix multiplication. Right? This is the derivation. See, whenever some formula is coming, it's better to understand the derivation of how it is coming and why it is coming. So, Amma? Hello? Is it okay? Right. But anyhow, for the competitive examination, this complete derivation is not required if you are able to understand. So if you have a cascade connection, multiply the ABC parameters of the both two-port networks or three two-port networks or four two-port networks. We will get the ABC parameters of the final two-port networks. Okay, Naman? Understood then? Suppose, now tell me, suppose I have please listen, I have three two-port networks. So suppose if you are unable to, we have only 1 minute time. Even if you are unable to give the answer right now, but at least try to analyze the problem and respond in the tomorrow's class. I have three two-port networks, and each two-port network I have the Z parameters. I have three two-port networks. Each two-port network having the I have the Z parameters of the each two-port network. Right? Now all three two-port networks are cascadely connected. All three two-port networks are cascadely connected. Now I want to calculate the Z parameters of the final two-port network after cascading. Anyone can give the just your view how you want going to solve the problem coming like this. Anyone can respond within 1 minute. Once again, I will repeat. I have three two-port networks, and I know the Z parameters of the each two-port network, and all three port networks are cascadely connected. Now I want to calculate the Z parameters of the final two-port network after cascade connection. So that is the problem. So try to think how you are going to solve. Just provide your comment. Just provide your comment. Anyone can.
VA equals to H11 into VD.
No. We have